Welcome students. In this class we will be going on to learn about partial fractions. In other words, how to integrate using the technique of partial fractions. So before we could do the topic, we would like to have a small review of the previous lesson. Now in the lesson, or I should say in lecture 4, we have seen certain types of integration. And also in previous lessons or previous lectures 3 and 2. So we'll start this lesson with this review. Now we've been given that integral f of x dx is equal to phi of x, and then we are expected to obtain the integral of x raised to the power of 5 f of x cubed times dx. So foremost, what I'm going to do is I'm going to consider integral x raised to the power of 5 f of x cubed times dx, and I'm going to rewrite this as x raised to the power of 3 times f of x cubed times x raised to the power of 2 times dx. So I'm actually splitting x raised to the power of 5 as x raised to the power of 3 and x raised to the power of 2. Now we have already learnt about substitution, so I wish to use the technique of substitution to simplify this given integral. So let me take x to the power of 3 to be equal to sum t. So this is going to give me 3 times x squared dx to be equal to dt. From here I can rewrite x squared dx to be as dt over 3. So this can be rewritten as integral. In the place of x cubed I substitute t. In the place of this x cubed I'll substitute t. In the place of x squared dx I will be substituting dt over 3. So I'll place this 1 over 3 over here. Now this is a combination of two functions, right? So what I will do is I will use integration by parts. Now by integration by parts, we would assign the value of u to be as t and the value of dv to be as f of t times dt. So differential of u would give me du, differential of t would give me dt, and integrating this would give me v. Now we have this particular information in the question, which is integral of f of x dx is equal to phi of x. Now this is actually integral of f of t dt. The only difference is instead of x I've got t, so this is going to be phi of t. Simple as that. Now if we were to use the integration by parts formula, it's going to be uv negative integral v du. So in place of u I'll substitute t, in place of v I substitute phi of t followed by a negative sign and the integral sign, and we got a v and a du. So v is going to be phi of t and my du is going to be dt. So this is exactly what we have got. Now we have to integrate this quantity. Now the solution is complete if we can revert back the variable t into the original variable x. Now it is also imperative to note here that we got a 1 over 3 there as a scalar quantity. So we will have to multiply this entire component with 1 over 3. So let me just place that 1 over 3 there. Now what I wish to do is I would revert every variable of t which is found here to the variable of x. So this is going to be equal to 1 over 3 times, in place of t I've got x cubed, and in place of t I need to place that x cubed followed by a negative sign and integral. Now in place of t I will have to place an x cubed. In place of dt I will have to place 3 times x squared dx, right? Because this is what is my dt. So I've got to place that. So this is going to be 3 times and x squared will be there and a dx will be there. So this is what we've got. Now what we have to do is we would have to, you can either stop here, or what you can do is you can scalar multiply the quantities. So if you were to scalar multiply every quantity by 1 over 3, you would get 1 over 3 times x cubed times phi of x cubed followed by negative 3 with 1 over 3, they get neutralized, giving us integral phi of x cubed. Of course, it's better that we place this x squared over here, x squared times dx. I hope you can see this x squared here. So this is the final solution. Of course, we need to place the arbitrary constant c. So this is a good place for us to draw the red line. Now this particular question will have some choices. So make sure that you are going into this question with the understanding as of how exactly we can evaluate this problem. So these are the steps that I've shown here. I hope you can practice them and gain mastery. So we'll move on to the next question. In fact, we are going on to the next topic, and the topic is partial fractions. So let's start off by doing questions in partial fractions. The foremost rule to apply partial fractions, let me state it here, is that the degree of the numerator should always be less than the degree of the denominator. If you are able to have this, only then you can apply partial fractions. Have that in mind. So this is a necessary rule, or you can state a necessary condition for applying partial fractions. So having mentioned that, let me just go on to give you the first example. We expected to integrate integral dx of x positive 1 times x positive 2. Now this is actually a product of two quantities, right? So what we will do is, we will first consider like this, consider the quantity without the differential operator and the integral sign. So which is 1 over x positive 1 times x positive 2. So I'm going to rewrite this as a over x positive 1 positive b over x positive 2. So now what we will do is, we will cross multiply. If we were to cross multiply, we would get 1 is equal to, a has got a denominator x positive 1, so we would only have a times x positive 2, plus b has a denominator x positive 2, so we will only have b times of x positive 1. Now our basic idea is to get rid of the quantities one by one. In other words, we will have to find a suitable x which upon substituting produces either of the terms to be as 0. So in this case, if I want to make b to be as 0, or the coefficient of b to be as 0, I will just take x to be as negative 1. So if I were to take this as 2, put x is equal to negative 1 in 2. So what happens when we do that? So this is going to be equal to a of negative 1 positive 2 positive b of negative 1 positive 1, and on the left side we got 1. So this one would produce a of 1, this one would be 0, and so I get a value to be equal to 1. So this is one quantity. Next, you will again have to choose a x so that this term becomes equal to 0. So in this case, I need to take x to be equal to negative 2 in 2. So therefore, what happens on the left hand side is just 1. So this is going to be a of negative 2 positive 2 positive b of negative 2 positive 1. So this is going to give me negative b. This is going to give me 0, and I got a 1 there. So therefore the value of b is negative 1. So I've got a value for a and I've got a value for b. So if I were to take this as 1, therefore I can rewrite 1 to be as 1 over x positive 1 times x positive 2 is now equal to 1 over x positive 1 positive of negative 1 over x positive 2. So therefore the original question, integral dx over x positive 1 times x positive 2 is now equal to integral of, just place this quantity. So this is going to be 1 over x positive 1 negative 1 over x positive 2. Of course you got the differential operator dx there. So let me just draw. Okay, so this is equal to, if you were to split it, is going to be integral dx over x positive 1 negative integral dx over x positive 2. So this is nothing but ln of x positive 1, and this is nothing but ln of x positive 2. I'm not placing the constant c as yet. Now we know that ln of a negative ln of b is equal to ln of a over b, right? By this formula, I can rewrite this as ln of x positive 1 over x positive 2, positive arbitrary constant c. So this is my final solution, and I've just applied the technique of partial fractions to get the result. So we'll move on to the next question, students. Now there might be a question. The question is, why do we need partial fractions, right? Why not we integrate this particular given question as it is? Of course, you can integrate it with some manipulation skill sets. So what I'm going to do, I'm going to give the solution of this particular integral using techniques of manipulation. Now we were given this integral, right? Integral dx over x positive 1 times x positive 2. Now the manipulation idea is I need to get rid of this term or this term so that there is just one particular term and it's simple to integrate. So that is the idea. So for that idea, what I will do is I will consider that there is a 1. Of course there is a 1 in the numerator, right? So I'm going to rewrite 1 to be as x positive 2, right? I don't have an x there, so I'm getting rid of this x, and at the same time I just have 1 here, so but there is a presence of 2 here, so I'll have to get rid of this, get rid of one more 1 from this 2. In fact, I need to reduce that 2 by 1. That's the idea. Now if I were to rewrite this, this is actually x positive 2 negative of x positive 1, right? So all is done just to represent this 1. So in place of 1, I can rewrite now x positive 2 negative of x positive 1 times dx divided by x positive 1 times x positive 2. Now this can be rewritten as integral x positive 2 times dx over x positive 1 times x positive 2, and there is a negative sign, negative x positive 1 times dx over x positive 1 times x positive 2. So clearly we can see that x positive 2, x positive 2 can be cancelled, x positive 1, x positive 1 can be cancelled, right? So if we were to cancel it, we would arrive at integral dx over x positive 1 negative integral dx over x positive 2. Upon integrating, this is going to give me ln of x positive 1 negative ln of x positive 2. I'm going to use ln a negative ln b, which is nothing but ln of a over b. So this is going to be rewritten as ln of x positive 1 over x positive 2 with the arbitrary constant c. So this is the final solution. So what is the take home point? Of course, if you are skillful in manipulations, you can integrate the quantity without the aid of partial fractions. But the much important or the most important questions that has to be posed here is it always possible to represent the numerator in a fashion by which we can reduce the integral so that integration becomes easy? The answer to that question would be not always, and that is the reason partial fractions are very important to learn and to obtain mastery. I hope you understood why we are very particular in learning this technique. So that would answer the particular question. So students, we have given this question, integral dx over x positive 1 times x positive 2 times x positive 3. So you got 3 terms there. So what I will do is I will start off like this. Consider 1 over x positive 1 times x positive 2 times x positive 3, and I rewrite this on the right side as a over x positive 1, positive b over x positive 2, positive c over x positive 3. So if we were to cross multiply, we would get 1 on the left side, and on the right side we would get a times x positive 2 times x positive 3, positive b times x positive 1 times x positive 3 positive c times x positive 1 times x positive 2. So our intention is to make these terms to be as 0. So foremost what I will do, I will start by making the term with c to be as 0. For that, let x be equal to negative 1. So we just place x is equal to negative 1 in 2. So let me name it as 2. So if we were to do it, this would clearly vanish because of the presence of x positive 1. This would vanish because of the presence of x positive 1. This alone will stay. So this is going to be a of negative 1 positive 2 times negative 1 positive 3. I can rewrite this as a of 1 times 2, which is nothing but 2 times a. Therefore a is 1 over 2. So that's a good value for us. Now what I will do, I need to get rid of this term. So for that, let me just take x to be equal to negative 3. If I were to take x to be as negative 3, this one will vanish, this will vanish, but this will persist. So 1 is equal to c times of negative 3 positive 1 times negative 3 positive 2. This is equal to c times of negative 2 of negative 1, which is nothing but 2 times c. Therefore the value of c is 1 over 2. So we have got this value for c, and now let me just get rid of this term. So for that, let x be equal to negative 2 in 2. So this term will vanish, so I would get 1 is equal to b of negative 2 positive 1 times negative 2 positive 3. This term is going to get vanished. So this is equal to b of negative 1 times positive 1, which is nothing but negative b. Therefore the value of b is negative 1. So rewriting the original question, we would have now integral. In place of this, I would substitute the values of a and along with their denominator. The value of a is 1 over 2 divided by x positive 1. The value of b is negative 1 divided by x positive 2. The value of c is 1 over 2 divided by x positive 3 times dx. Now I can rewrite this as 1 over 2 times integral dx over x positive 1 negative integral dx over x positive 2 positive 1 over 2 times integral dx over x positive 3. Now this is going to be 1 over 2 times ln x positive 1 followed by negative ln x positive 2 followed by 1 over 2 times ln x positive 3. Now I can club a few things. So if I were to take this 1 over 2 to the head of ln, so let me do that, because a times ln b is equal to ln b raised to the power of a. Right, so I can rewrite this as ln of x positive 1 raised to the power of 1 over 2. This stays as it is. This is going to be ln of x positive 3 raised to the power of 1 over 2. So I've got ln root of x positive 1 followed by ln root of x positive 3, and I've got a negative ln of x positive 2. So this is what I have got. So now we need to realign these things and write it in a crispy form. Now you can use logarithmic rules to further simplify it, but in the interest of time, what I will do, I will just wrap it up over here. So this will be an ideal place to have a constant c. So that is fine, and I will draw the red line over here, and that will complete the result. Either you can draw it here, or if you want, you can simplify it further and then rewrite it. So this is alright, and we'll move on to next type. Now this is called as type 2 partial fractions. Now this is applied when you have repeated linear factors. So I'll give you a beautiful illustration for that. Imagine you have to integrate integral 3x negative 2 over x positive 1 raised to the power of 2 times x positive 3 times dx. Now let me just consider the given integrand, which is 3x negative 2 over x positive 1 raised to the power of 2 times x positive 3. Now clearly you can see that x positive 1 is repeated. So that is why we call it as repeated linear factors. So we start with a over x positive 1, that's one term, positive b over x positive 1 raised to the power of 2. That's the second term, and the third term would be c over x positive 3. So this is the way you need to represent the integrand. Now upon cross multiplying, on the left side you get 3x negative 2, on the right hand side you get a times x positive 1 times x positive 3, positive b times x positive 3, positive c times x positive 1 raised to the power of 2. As I mentioned earlier, our objective is to make these terms 0. And we can do it in proceeding manner. In other words, successively we can make these quantities 0. So for that I will start either with a. So I will say let x be equal to negative 1 in, I'll take it as 2. And because of that, this is going to be, on the left is going to be 3 of negative 1 negative 2 is equal to, this term is going to be 0. But this term is going to be b of negative 1 positive 3. Of course, this term is going to be 0, right, when x is equal to negative 1. So I can rewrite this as 2 times b. So on this, on the left hand side, it's going to be negative 3 negative 2 is equal to 2 times b. Therefore, you got negative 5 over 2 is equal to b. So the value of b is negative 5 over 2. Next, what I would do, I would make this term to be 0. So let x be equal to negative 3 in 2. So what happens on the left side? It's going to be 3 of negative 3 negative 2. This is going to be 0. This is going to be 0. This is going to be c of negative 3 positive 1 raised to the power of 2, which is nothing but negative 3 positive 1 is negative 2. You got a c there. You raise it to the power of 2. This is going to be 4 times c. On the left side, 3 times 3 is 9 with a negative sign, followed by a negative 2. So therefore c is equal to 9 negative 2. In fact, negative 9 negative 2, that's going to be negative 11 over 4. So that's the value for c. So now we have got b and we have got c. Now the idea is to obtain the value for a. Now we have removed b, we have removed c. Now the condition is to get the value of a. What I will do is I will just take let x be equal to 0, because if I were to take x is equal to negative 3, a will also vanish. If I were to take x is equal to negative 1, again a will vanish. So to prevent that, we will take x to be equal to 0 in 2. So that would mean I would get negative 2 on the left hand side, and on the right hand side this is going to be a of 0 positive 1 times 0 positive 3, positive b of 0 positive 3, positive c of 0 positive 1 raised to the power of 2. This is going to give me 3 times a, positive 3 times b, positive c. On the left side is going to be negative 2, and my b is going to be, I think instead of this I need to place the value of b, which is negative 5 over 2, and the value of c is negative 11 over 4. So this is going to be 3 times a, negative 3, I should say positive 3 negative 5, that's going to be negative 15 over 2, negative 11 over 4, and I got a negative 2 here. Now I need to move everything to the left hand side. So it's going to be negative 2, positive 15 over 2, positive 11 over 4 is equal to 3a. I take the LCM as 4. This is going to give me negative 8. This is going to give me 30, and 11 is equal to 3 times a. So this is going to be 30 and 11, 41 negative 8. And that has to be divided by 4 is equal to 3 times a. So 41 and 8, this is going to give me 33, right? I carry 1 there, I get 3 and a 3, so that's fine. So I get a 33 divided by 4 is equal to 3 times a. But 3 can divide here 11 times, so therefore my value of a is 11 over 4. So I've got A, I've got B, I've got C. So let me just use this space over here. So I need to, let me show you this. So I need to use the values of A here. So therefore integral, instead of this I'm going to place here the values for A, B, C and the respective denominators. So A is 11 over 4 divided by x positive 1, and my value of B is negative 5 over 2 divided by x positive 1 raised to the power of 2, and the value of C is negative 11 over 4. So negative 11 over 4 divided by x positive 3 times dx. So if I were to split these quantities, so this is going to be 11 over 4 integral dx over x positive 1 followed by negative 5 over 2 dx over x positive 1 raised to the power of 2, negative 11 over, so I've got a 11 over 4 and 11 over 4. So 2 11 over 4 are appearing. So dx over x positive 3. Now this we know. For this, let me just consider, let x positive 1 be equal to t. So dx is equal to dt. So this is going to be integral, in place of dx I substitute t, in place of x positive 1 it's going to be t squared. I'm not placing the constant as yet. This is just a simplification part which is shown for the viewer's understanding. So if I were to push this t squared to the numerator, it is going to be t raised to the power of negative 2 and dt, and I integrate this, I get t raised to the power of negative 2 positive 1 negative 2 positive 1, which is t raised to the power of negative 1 divided by negative 1, which is 1 over t with a negative sign, which is nothing but negative 1 over x positive 1. So this is what we will get if we make the substitution in this fashion to integrate this quantity. So that's fair enough. So now coming back to the integral of the first quantity, that's going to be ln of x positive 1. The second quantity is going to be 5 over 2. There's already a negative sign, so this is going to be positive times x positive 1. That's fair enough. Followed by negative 11 over 4 ln of x positive 3. Now I got 11 over 4, 11 over 4. So let me take that 11 over 4 out, and that would give me ln of x positive 1 negative ln of x positive 3 positive 5 over 2 times x positive 1. Of course I need to place the arbitrary constant c. Now you can rearrange this, right? Ln a over ln b. Now if I were to do that, let me just use this space to wrap up the solution. So this is going to be 11 over 4 times ln of x positive 1 over x positive 3. I'm using ln a negative ln b formula. Okay, positive 5 over 2 times x positive 1 positive c. So this is a good place for us to draw the red line. So that is the solution for this question. Of course it is a little bit lengthier, but with some considerable practice you will be able to achieve the outcomes. Students, we are heading on to the next type. This is you can call it as type 3, and the title is quadratic factors that are non-reducible. The type is the better word is non-factorizable. Now what exactly does it mean by non-factorizable? Now suppose you are given an integral like this, say integral dx over x positive 1 times x squared positive 3x positive 2. Now this is a quadratic equation, right? But you can very well rewrite this quadratic equation as x positive 1 times x positive 2. Now why am I writing it like this? Just take x positive 1 and multiply it with x positive 2. What do you get? X into x, x squared, 2x positive 2, which is x squared positive 3x positive 2. This is exactly the equation that we have in the denominator. So what am I trying to show here? If we are to be given a quadratic equation, if it is factorizable, then it's well and good. It's simple to solve using partial fractions. But what if it isn't factorizable? So that is exactly what we are going to look into this particular question. We've been given integral dx over x positive 1 times x squared positive 1 and clearly this is a quadratic equation, but it isn't factorizable. So in cases like that, what we will have to do is we will have to consider the partial fraction of type 3. So I take the integrand x positive 1 times x squared positive 1, and I rewrite this as a over x positive 1 for the first quantity. For the second quantity, the degree is 2, so we will have to represent it as bx positive c over x squared positive 1. So this is the standard format by which we will have to handle quadratic equations which aren't factorizable. So if we were to cross multiply, I would get 1 is equal to a times of x squared positive 1 positive bx positive c times x positive 1. So you might be wondering, how are we going to solve it? It's very simple to solve this. So foremost, what I'm going to do is I'm going to take values for x in this particular equation, or for this particular equation. So first what I will do is I will try to neutralize this quantity. So let x be equal to negative 1 in 2. So therefore what happens here, left hand side is going to be 1 and the right hand side is going to be a of negative 1 squared is going to be positive 1 followed by a positive 1. This is going to become 0 because when x is equal to negative 1, this entire term will vanish, giving us 0. So I've got 2 times a is equal to 1, therefore the value of a is 1 over 2. So I've already got one value. Now to get the other value, in fact other two values, I would take x is equal to 0 in 2 again. This one would mean I would have a of 0 positive 1 and then followed by b of 0 positive c of 0 positive 1. So I get an a here, b is already gone, but I have a c here. On the left hand side I got 1, but the value of a is 1 over 2, so that has to be added with c. So this would mean I get 1 negative of 1 over 2 is equal to c, therefore the value of c is 1 over 2. So fine, I've got the value for a, I've got the value for c, now all it remains is the value for b. Now just take any random value for x in this case. Now I already taken x is equal to negative 1, I'm going to take x is equal to 1 in 2. Now this is your choice. I'm taking it as 1 because it's easy to simplify, but you can take any value you want. So on the left side is going to be 1, followed by on the right side is going to be 1 positive 1 positive x is 1, so it's going to be b positive c of 1 positive 1 is going to be 2. Now this is going to be 2 times a and followed by b my c, so it's going to be 2b and 2c, which is equal to, my a is 1 over 2, so substitute that. I don't know the value for b, but my c is 1 over 2, substitute that. Now clearly you can see that 2 can be cancelled, 2 can be cancelled, so I get 1 positive 2 times b positive 1, which is nothing but 2 positive 2b. On the left side I get a 1. I'm pushing this 2 to the left side, so it's going to be 1 negative 2 is equal to 2b, which would mean negative 1 is equal to 2b, therefore the value of b is negative 1 over 2. Fine. So I've got the value for a, I've got the value for b, I've got the value for c. I need to substitute it in 1. So therefore the integral which was given to us as dx over x positive 1 times x squared positive 1, which has been rewritten as a over x positive 1 positive bx positive c over x squared positive 1 times dx, has now been rewritten with the value of a, b and c. The value of a is 1 over 2, place that. The value of b is negative 1 over 2 times x. The value of c is 1 over 2, so place that. This has to be divided by x squared positive 1 and you have the operator dx there. So I can split it and rewrite this as 1 over 2 times integral dx over x positive 1 negative 1 over 2 times integral x times dx over x squared positive 1 positive 1 over 2 times integral dx over x squared positive 1. Right? Fair enough. Now let me show you how to get these values. So I'm just going to show you the working on this side. Now this is straightforward. but this one, consider x times dx of x squared positive 1. So what I'm going to do, I'm going to take, let x squared positive 1 be equal to t. I differentiate both sides. I get 2x dx is equal to dt. I have only x dx there, so x dx is going to be dt over 2. I substitute the value there. So this is going to be dt, 1 over 2 comes out. X squared positive 1 is t, so this is going to give me ln t. But my t is what? T is x squared positive 1. So I can have that value there. Of course, you got to have an arbitrary constant, but it doesn't matter. We are going to place the arbitrary constant over here. So that's for the first part. This is going to be tan inverse of 1. So let me write them down. So this is going to be 1 over 2 ln of x positive 1 negative 1 over 2, because I have not taken that 1 over 2 here. So I already have a 1 over 2. I need to substitute that 1 over 2. So it's going to be 1 over 2 times ln of x squared positive 1. That's okay. So it's going to be 1 over 2 times tan inverse of x. And if you want, you can multiply these constants, because you got 1 over 2, 1 over 2, 1 over 2. So you can take that 1 over 2 out. If I were to take that 1 over 2 out, this is going to be ln of x positive 1. Let me, if you want, it depends on you, whatever value, I mean whichever term you want to place. Okay, anyway, I'll just place this negative 1 over 2 times ln of x squared positive 1 followed by tan inverse of x, positive arbitrary constant c. So this is a good place for us to draw the red line, and this is the solution for the question. So that's fine, and you need to go through this, understand it, and then redo it, and then repeat the process until you gain the mastery of this topic. Students, there are two important integral formula that you will have to know, which is integral dx over a squared negative x squared is equal to 1 over 2a ln of a positive x over a negative x. This is formula 1. And you got the other formula. Of course, you have the arbitrary constant c. The next one is integral dx over x squared negative a squared. Now this is equal to 1 over 2a ln of divided by x positive a positive arbitrary constant c. So you have to be a little bit cautious when you're writing the formula. So this is x minus a over x plus a, and in this case this is a plus x over a negative x. So what I'm going to do, I'm going to establish the proof for these two important results by means of partial fractions. That's exactly what I'm going to do. So question 1, I'm going to prove it, that integral dx over a squared negative x squared is indeed equal to 1 over 2a ln of a positive x divided by a negative x positive arbitrary constant c. So let me just consider the left hand side, consider LHS. So what do we have in LHS? Integral dx over a squared negative x squared. I can rewrite this as integral dx over a negative x times a positive x, right? So we got two components here. Now let me just assign, consider now 1 over a negative x times a positive x. So this is going to be equal to a over a negative x positive b over a positive x. Now if I were to cross multiply, I would get 1 is equal to a times a positive x positive b times a negative x. I take this as 2. Now what I wish to do is, I would like to take, let x be equal to negative a in 2. So if you were to do that, you would get 1 is equal to negative a, this becomes 0. So this is going to be b of a negative sign of negative a. So this is equal to b of a positive a, which is nothing but 2a times b. So therefore the value of b is 1 over 2a. That's fair enough. Now let me take x to be equal to, I need to get rid of this term. So I'm going to take x to be equal to a. So if I were to take x to be equal to a into, on the left side I would get 1 is equal to a of a positive a. This is going to be 0. So this would be equal to 2 times a of capital A. Therefore capital A is 1 over 2a. So I've got a value and a b value. Therefore the given integral, what has been given to us, integral dx over a squared negative x squared, which has been rewritten as a over a negative x positive b over a positive x times dx, is now rewritten again with the value of a, which is 1 over 2a over a negative x positive, the value of b is 1 over 2a over a positive x times dx. Now I'm going to rewrite this given integral as 1 over 2a integral dx over a negative x positive 1 over 2a integral dx over a positive x. Now this is simple to integrate, but this one we need to be a bit cautious because it has got a negative sign. So let me just show you by substitution. So we were to integrate integral dx over a negative x. Now I'm going to take, let a negative x be equal to t. When I differentiate, I get negative dx is equal to dt. There aren't any negative sign here. So this would mean dx is equal to negative dt. So rewriting this with the substitutions, in place of dx I get negative dt. In place of a negative x I get a t. I integrate this, I get ln t. But my t is a negative x, so I need to substitute that. The most important observation to be made here is the presence of a negative sign. So this is going to be rewritten as negative 1 over 2a ln of a negative x followed by 1 over 2a ln of a positive x. Now I can rewrite this as 1 over 2a with the positive quantity first, ln of a positive x followed by ln of a negative x. Now this is actually ln of a negative ln of b. What is that? That's nothing but ln of a over b, right? We know this formula. So by this formula, this is equal to 1 over 2a ln of a positive x over a negative x plus arbitrary constant c, which is exactly the required formula which has been given to us. So that's a good place for us to draw the red line. So the most important observation is to pay heed that there is a presence of a negative sign before x. Students, I would like you all to try the result for the second formula which I have just shown you, and you can post it in the comment section if you achieved the result. Now we will head on to the next question. Now this is a nice question, and we are expected to integrate integral dx over x positive 1 times x squared negative 1. Now this is actually looks a little bit tedious, but it can be simplified. Now why it can be simplified? Because the quadratic that we see here is factorizable. So that is the catch here, because it is not x squared positive 1, it is x squared negative 1. So what I'm going to do, I'm going to rewrite this as integral dx over x positive 1 times x squared negative 1. This is actually x negative 1 times x positive 1. Now I can club x positive 1 with x positive 1. So thereby I would get integral dx over x positive 1 raised to the power of 2 times x negative 1. So this is fair enough. Now I'm going to consider the integral now. So consider 1 over x positive 1 raised to the power of 2 times x negative 1. I'm going to rewrite this as a over x positive 1 positive b over x positive 1 raised to the power of 2 positive c over x negative 1. Now cross multiplying would give me a times x positive 1 times x negative 1 positive b times x negative 1 positive c times x positive 1 raised to the power of 2. On the left side I'm going to get 1. Now let me just change this question. Instead of just placing 1 and simplifying it, imagine we have got a term as x squared positive 2. Let me just take a term as x squared positive 2, x squared positive 2 and x squared positive 2. So there wouldn't be any impact in this case. right? So this is going to be just x squared positive 2. So x squared positive 2 remains as it is. Now it would come into play when we are taking the values of x. As I mentioned to you, our objective is to get rid of these variables or get rid of these quantities a, b and c one by one. So foremost, what I will do, I will try to get rid of this c. So for that, let x be equal to -1 in, let me take this as 2, and that would give me on the left side, this is -1 square, that's going to be 1 positive 2. On the right hand side, this is going to vanish, x is equal to -1. X is equal to -1, this is going to vanish, but this will remain. So -1, which would give me -2 times b. On the left hand side, I already have a 3, so 3 is equal to -2b. Therefore my value of b is going to be 3 over 2 with a negative sign. So that's critical. Now let me get rid of this term now. So let x be equal to 1 in 2. So if I were to take x equal to 1 in 2, this term is going to go off. X is equal to 1, this term is going to go off. This term is going to stay. So c of 1 positive 1 raised to the power of 2. On the left hand side, x is equal to 1. This is going to give me 3. So this is 3 is equal to 1 positive 1, 2. 2 squared is 4. So 4 times c. Therefore the value of c is going to be 3 over 4. So we have got the value of b. We have got the value of c. Now let us get the value for a. Now what I wish to do is, let me just take, because if I were to take x is equal to 1, right, this is going to get vanished, but a term will also get vanished. So there's no point in taking either 1 or -1. We have already exhausted. So what we have to do is simply take x is equal to 0. If I were to take x is equal to 0 in 2, on the left hand side I would get 2. On the right hand side I would get a of 0 positive 1 times 0 negative 1 positive b of 0 negative 1 positive c of 0 positive 1 raised to the power of 2. So this is going to give me negative a, this is going to give me negative b, this is going to give me positive c, and on the left hand side I've got a 2 here. Now the value of b is negative 3 over 2. So this is going to be positive 3 over 2 followed by a 3 over 4 and a negative a there. So let me draw a line here so that I can use the space here. Now if I were to move everything to the left hand side, it's going to be 2. Negative 3 over 2 negative 3 over 4 is equal to negative a. I take the LCM as 4. This is going to give me 8. This is going to give me 6. This is going to give me 3 with the negative a here. So 8 negative 6 would give me, in fact negative 6 negative 3 negative 9 added with 8 would give me negative 1 over 4, which is equal to negative a. So therefore the value of a is 1 over 4. Now while evaluating, it's always appreciated, or I would say it's always better to exercise some caution, specifically in getting these constants. So the chances of making an error is high. So I've got the value of a, I've got the value of b and c. Now we need to substitute them. So I need to use some space here. So let me try and use this space here. So this is going to be the change, right? So I'm going to start with the integral. So therefore the integral is going to be, my value of a is 1 over 4 divided by x positive 1, that's fine, and my value of b, I've got the value of b as negative 3 over 2. So negative 3 over 2 divided by x positive 1 raised to the power of 2, and then the value of c is 3 over 4 divided by x negative 1. So this is smooth and it's not much complicated. So this one is going to give me, let me rewrite it like this, 1 over 4 times integral dx over x positive 1, and then negative 3 over 2 integral dx over x positive 1 the whole squared, followed by 3 over 4 integral dx over x negative 1. This is what we have got. Now for the first quantity, the first one will give me 1 over 4 ln of x positive 1. The second one is going to give me negative 1 over x positive 1. We already know how to integrate this, right? If I were to substitute x positive 1, if you are not sure, okay, let me just show you that, just in case if you are not sure. So we are given integral dx over x positive 1 raised to the power of 2. What I'm going to do, I'm going to take x positive 1 is equal to sum t. I differentiate this, I get dt. So in place of dx, I'm going to have dt. In place of x positive 1, it's going to be t. But the degree here is 2, so this is going to be t squared. I will move this t squared to the numerator, so it's going to be negative 2 there. And now if I were to integrate, it's going to be negative 2 positive 1 divided by negative 2 positive 1. This is going to be negative 1 followed by a negative 1. I can push the t down, so it's going to be 1 over t with a negative sign. And if I were to replace it, it's going to be negative 1 over x positive 1. So this is exactly what I've done. Negative 1 over x positive 1 followed by 3 over 4 ln of x negative 1. So if you were to rewrite this, I want to rewrite this. Let me rewrite this over here, the solution. So this is equal to 1 over 4 ln of x positive 1, negative, negative, positive. So it's going to be 3 over 2 times x positive 1. And then you have positive 3 over 4 ln of x negative 1 plus arbitrary constant c. So that's a good place for us to draw the red line. Students, of course, if you want to simplify further, you can use logarithmic formulae, but I think this is the best place for us to stop. Students, I would like to show you one variation away from partial fractions. Now let us consider this question: integral x squared positive 1 over x squared negative 5x positive 6 times dx. Now clearly you can see that the degree of the numerator and the degree of the denominator are one and the same. In fact, we would not be able to apply partial fractions because they fail the required condition for the application of partial fractions. So in that case, what we have to do is we will have to use long division. So what we'll have to do, we'll have to divide the numerator by the denominator. So in this case, the numerator is x squared positive 1, so we'll have to divide it by the denominator x squared negative 5x positive 6. So clearly 1 will be the quotient there. So I multiply by 1, I get x squared. Now what I can do is I can actually rewrite x squared positive 1 as x squared positive 0 times x, because there isn't any x term there, followed by 1. So in that case we would be little bit at ease in placing the quantities. So 1 multiplied by negative 5x would give us negative 5x followed by positive 6, and then we will have to change the sign, negative and positive, positive, negative. So these two gets cancelled. This would be 5x negative 5. So this is the quotient, this is the remainder. So what we are going to do is we are going to write x squared positive 1 divided by x squared negative 5x positive 6 as 1 positive 5x negative 5 divided by the quantity x squared negative 5x positive 6. So this is the way we will have to write. So therefore if we were to integrate this, this is going to be integral of 1 positive 5x negative 5 divided by x squared negative 5x positive 6 times dx. So I can rewrite this as integral dx positive integral 5x negative 5 divided by x squared negative 5x positive 6 times dx. So this is what I have got. So now from here we can move on to integrate the quantity. So this quantity is going to give me x, but in this case we need to pay attention. So what I will do, this is straightforward, we all know that. So I'm going to consider integral 5x negative 5 divided by x squared negative 5x positive 6 times dx. I'm going to take 5 out. I would get x negative 1 times dx divided by, now x squared negative 5x positive 6. This is a factorizable quadratic equation. So I'm going to factorize it as x negative 2 times x negative 3. That's fine. So now take the integrand x negative 1 divided by x negative 2 times x negative 3 and write it as a partial fractions a over x negative 2 positive b over x negative 3. So if I were to cross multiply, I get x negative 1 is equal to a over x negative 3 positive b over x negative 2. I'm going to take x to be equal to 2 into, this is 2, so this would give me 2 negative 1 is equal to, this will vanish, so it's going to be a of 2 negative 3, and that would mean I have 1 is equal to negative a, so a is equal to negative 1, that's fine, that's fair enough, and then x is equal to positive 3 in 2, so this will vanish, this will give me b of 3 negative 2, this will give me 3 negative 1, I get a 2 is equal to b, therefore the value of b is 2, so I got a a and a b. So if I were to write the integral, this is going to be negative 1 over x negative 2 times dx. Anyway, I'll just write the terms first with this dx, then I will split them as negative dx over x negative 2 positive 2 times dx over x negative 3. This is going to be ln of x negative 2. This is going to be 2 times of x negative 3. This quantity is integrated. Take this and place this over here. So if I were to write this, this is, so now I'm going to take this all and place it in the original system which we started off. So that would give us x positive 5 times of, and this is going to be, I'm going to write the first term 2 times ln of x negative 3 negative ln of x negative 2 positive arbitrary constant. See, we can rearrange this. So this is going to be x positive of ln of x negative 3 raised to the power of 2 negative ln of x negative 2 positive c. Now this is ln a negative ln b, so this can be rewritten again as x positive 5 times of ln of x negative 3 raised to the power of 2 over x negative 2, and arbitrary constant has to be added, and I think this is a good place for us to draw the red line, students. Thank you.